So in this video we're going to look at conditional probability and using Venn diagrams to try and help us to get to our answers. Now we're given these three bits of information. The probability of not A is 0.6. The probability of B given A has already happened is 0.5. The probability of not A given B has already happened is 0.6. And we want to find these five different probabilities which all look very similar but with some discrete changes. So A given B has happened, A given not B has happened, B given not A has happened, not A given not B has happened. So that's quite an interesting one. And then the reverse of those. Now these two, just because they're reversed doesn't mean they're necessarily given the same answer. So first of all we need to find some stuff out about this Venn diagram and then we can try and get these answers. So the probability of not A is 0.6. So we know the probability of A is going to be 0.4. So it's 1 minus that will always give us that. And we're given that and we're given that. But ideally we want to try and find this intersection. So what we could do, we could use this and this to find the intersection. So the formula we can use is the probability of B given A has already happened is the probability of B intersection A over the probability of A. Now we've got probability of A, we've got the probability of B given A, so that's 0.5 equals the probability of B intersection A, and probability of A is 0.4. So that will give us the probability of B intersection A, 0.5 times 0.4, so that will give us 0.2. So probability of B intersection A is 0.2. So now with that, that can really help us out now because that's our centre part here, the connection between the two. So here we've got 0.2. Probability of A is 0.4, but that encloses all of the circle. So this bit here is going to be 0.2 as well. Now probability of B, we ideally could do with finding the probability of B. But we don't have enough information at the moment. So now what we could do is we've used this to find that. Now what about this? Probability of not A given B has already happened. So that would then require us to know the probability of not A intersection B. So that's the intersection of not A with B. Now we don't know what that is just yet, but what I could do is I could put an X in there. And then probability of B, that would be 0.2 plus X. So I could do something with this and try and manipulate some algebra to try and get us to our answer. So let's just draw a line down here. Let's have a go at this. So this probability of not A given B has already happened. That would probably be the probability of this. So not A intersection B over the probability of B. So now if I call that X, I'm going to have two variables, but I'm going to know what the result, two variables, but the variable in the numerator and denominator will be using the same X, but it will be set equal to the same. So this is 0.6. And that would equal that intersection. So not A intersection in B. So not A intersection in B. That there will be X. And then the probability of B is X plus 0.2. So with some manipulation of this, I can then try and find my X. So if I cross multiply this one, so do 0.6 times that and bring it to here. So then I'll have 0.6x plus 0.6 times 0.12, times 0.2 is 0.12, and that equals x. So now bring this over to the other side, and then I'll have 0.4x equals 0.12, in which case x would be 0.3. So if x is 0.3, I can now finish off this table. So that becomes 0.3. Actually, I'm going to leave it as x equals 0.3 because that's what we just calculated here. And then we can know probability of B. So probability of B, that's going to be 0.2 plus 0.3, so that's 0.5. And the probability of not A intersection B, that's just going to be this bit here, so that's going to be 0.3. Okay, so now we can have a go now at calculating the rest of our probabilities. Okay, so probability of A given B has already happened. So that is the probability of A intersection B over the probability of B. So A intersection B is 0.2. Probability of B is the total of this, which we've got here, which is 0.5. So that would give us 2/5. Okay, so now next conditional probability. The probability of A given not B has already happened. So that's the probability of A intersection not B over the probability of not B. Well, probability of not B, that's pretty straightforward because we know B. So probability of not B, if I just write that one here, that would also be 1 minus that, so it's almost the same. Well, it is the same, 0.5. So then I've got 0.5, and A intersection with not B, that's 0.2. So that's just going to be this little segment there. So that, interestingly, is also 2/5. Okay, now probability of B given not A has already happened. So it's the probability of B intersection not A over the probability of not A. So B intersection with not A, that's 0.3. That's this bit here. And the probability of not A, so not A is all of the other stuff. So not A is 0.3. And then now we need this bit here, which is not enclosed in the circles, which is 0.2, 0.4, 0.7. So this bit here is going to be 0.3. So not A will be 0.6. So then that equals 1/2. Okay, now we've got probability of not A given not B has already happened. So that's the probability of not A intersection not B over the probability of not B. Okay, so what's that one going to give me? So probability of not A intersection with not B, so not A intersecting with not B, that's just going to be 0.3. And then the probability of not B, that's going to be 0.5. So then that equals 3/5. And then the last one, the reverse of this one, so that's the probability of not B, let's write that down correctly, not B intersection not A over the probability of not A. So that's the same as the one on the previous question, so that's 0.3. So you can write the intersection either way round, it doesn't matter, it still gives you the same answer. And the probability of not A is 0.6. So that also equals 1/2. Okay, so that completes all of our probabilities of our conditional variety, and we've got a link below you can click on and you can see some other videos with some similar questions on. Okay.